Batos Capacitor Leakage meter. That is the subject of today's video. And I've got two different sort of instruments that I made myself. The reason why I made it myself, because it gives me more versatility than any commercially available, which are quite expensive, but yet does not give me that scope of and facilities that I would like to actually do on the capacitors to measure the leakage. First of all, let's start with the leakage. What is leakage? If you look at it over here, here is the basic capacitor. Okay. Now, in a previous, in the next video actually, within the capacitor you get basically two different phenomenons that will manifest. And one is ESR, equivalent series resistance, and then leakage resistance, which is measured across the capacitor. How much current is actually flowing through the capacitor. That is the subject of today's video. Now, in electrolytic capacitors, you will always, even if it's a good capacitor, you will always measure residual leaking capacitance. Residual leaking current. No matter how good a capacitor is or what brand. But nonetheless, each manufacturer has got basically some kind of a chart, prescribed chart, and they have come to a particular sort of standard. What is acceptable, what is not acceptable, leakage currents for electrolytic capacitors, different values, different shapes, different voltages, and so on. And for the non-polarized capacitors, where it's a polyester, polycarbonate, paper capacitor, any sort of make of capacitor. Now, the reason why I have got two is this particular instrument, for more precision, I basically can measure up to 70 volta. Okay, with this one here, I can measure anything. With this unit, I can generate up to something like 450, yeah, precisely 450. If I read it here on the panel meter, 450. So wherever voltage I apply, right now it's in off position, and for safety this switch is actually shorting out these circuits because it can be little. Okay, although it's not a big current because it's current limited within the electronic unit, still it can be little because it's extreme voltage. So this one here basically has got a special light that can generate the light if there is because it's in series with the capacitor, and with a clever circuitry, electronic circuitry, it will pass the current, and it will keep on leaking, no matter how good the capacitor, because there's always, due to the electrolyte that's in between the two plates, as you see it here, where I'm pointing with a pencil, they like a electrolyte, like a gum or whatever electrolyte, which is a top-notch secret from every manufacturer, because that governs the quality of the capacitor also. So everybody keeps it as a trade secret. But nonetheless, most of the manufacturers, they got prescribed formulas and prescribed procedures and prescribed charts that one can follow, something like this, and procedures. And that's what I have done. I have summarized from the manufacturers their recommended leakage currents. And if this unit, this light will light up, showing that the capacitor is passing as I apply the voltage. In this case, let me take this particular cap. Okay. Now this capacitor here, if you look at it very carefully, it's a 2.2 microfarad 250 volta. Okay, I already got it set up to 250 volta on the panel meter. So now it is in off position, and a way I can choose low voltage or a very extreme high voltage up to 450 volta. And I can precisely adjust because the manufacturer specifies, in order to test the capacitor properly, okay, you have to take into account its, and you have to test it at its maximum operating voltage. So now that's what I'm doing. This is 250 and I'm applying 250. If you look at it very carefully, let me try to bend. I don't know if you can actually see it. On the meter, it's at 250 volt right now. Of course, it's off because I have switched it off in an off position. I have left it in an off position. All right, now let me connect up a cap and then do the actual measurements. Now what you will see, okay, right now capacitor is empty. Okay, and when I switch on to on, I will apply 250 volt voltage to this capacitor, and this light will light up. If the capacitor has got a leakage, okay, it will, of course, it will light up because it's charging up and passing the current. But once it reaches the full potential and the plates get saturated, it should cut off. But due to the normal sort of phenomenon, it will keep on leaking a little bit, and you will see the light will just flick a little bit top in, which is normal. Where for the non-polarized capacitors, any type of non-polarized capacitor, there mustn't be any residual leakage. If there is, that means that capacitor is useless. You must chuck it away, must not use it. All right, on that note, let me switch it on to on position. Watch the light here right now. Okay, look at it there. Okay, charges up the cap, disappears. Now, that is the residual. Okay, now the longer I keep it, the longer the interval between the on-off. Okay, because there will always be charging and discharging, charging and discharging. And as I said, gets discharged via this resistor. Now, to give you an idea, okay, and that tells me that this capacitor is 100%. It's doing what it's supposed to do. Okay, it's not staying bright. Okay, let me switch it off again and look at it, how bright it is. Oh, sorry, let me just do it this way. All right. Can you see how bright it was? Okay. Now, if it stays that bright, that means it's leaking. And it stays permanently on, even at half or whatever light, and it's permanently on, that capacitor is useless. You must chuck it away. Okay, now let me, right now it's discharging the capacitor. So now it's basically safe for me to touch. Okay, you can see. All right, now let's try another one. Let's take a non-polar capacitor. Okay, now this capacitor is 250 volt and it is exactly 4.7 microfarad, very high quality. I like these capacitors. Okay, now, okay, let me just do this. Connect it up. Okay, switch it on. All right. Okay, now it's connected. Now watch the light. How much brighter it will. Again, it's a 250. I don't have to adjust the instrument because it's already, I have set the voltage through this wire and with the instrument and with this sort of gadget that I've got also on the outside behind the panel meter, the actual voltmeter. Okay, watch now the light. Can you see it? It takes a bit longer because it is a bigger value capacitor. Now, there must not be any residual light. There must not be leakage. If we see a little bit of leakage through the capacitor. Now, to prove the point, I have got, let me just find it here. Okay, I have got a 10 megohm resistor, okay, which I'm just going to put in a, and I'm going to put it across. And the instrument is so sensitive that it will detect the leakage caused by this resistor. In other words, it will be passing the current, and it will indicate, yeah, that, hey, something is wrong with that capacitor. I'm simulating the internal resistor within the capacitor. This particular capacitor, that one over there on top. Okay, watch now. It will, okay, watch. Can you see it? Can you see it? Okay, I'm not making a good connection. Let me just, sorry, let me just do this. No, come on now. All right, watch it. Can you see it? The instrument, this instrument is so sensitive that it's measuring a 10 a voltage across 10 megohm resistor, which gives you a current of in microamps type of thing. Okay, but this type of capacitor must not have any leakage whatsoever. No microamps, no half a microamp or nanoamp or anything like that. Okay, the reason why it lights up when you say, okay, I'm just going to remove the resistor because there is a 250 volt there. I'm going to switch it off here again. Now watch now, again, now it's discharging the capacitor via the switch. I switch it on again, watch it, charges it up. Once it's charged, that's it. This capacitor has passed the test. Okay, so it's 100%. Let me disconnect it, discharge it. Okay, so I basically demonstrated. Now let me connect even the resistor over here. Okay, let me switch it on. Can you see? Right now it's on. Nothing is connected. Okay, now I'm going to connect that and simulate the resistor within the capacitor, where it's electrolytic or non-polar capacitor. Let's assume it capacitor is leaking, and that's a 10 megohm, 10 million ohm. Okay, now watch it there. Oops, watch it there. It's detecting, although it's extreme high resistance, the instrument is so sensitive that actually picks up that minute current that's going through that very high resistance. Okay, so that's a proof that this instrument is highly, highly accurate, and I trust it 100%. And I like it because I can adjust the voltage basically from, and I use this instrument anywhere from, say, 90, 80 volta to 450 volta. And this one here I use from 0 up to 70 volta for a bit more precision and so on. Now remember one thing, the larger the value of the capacitor, the longer the light will stay on until it's fully charged, because it will take some time because it's a minute current that the unit is giving into capacitor. That way it will take, for say for example, I'll give you an example that I have made, a 330 microfarad, a charging time will vary from like 1 minute to about 10 minutes, depends on the voltage, whether it's a 63 volta or whether it's a 100 volta, 160, 250, 330, or it's a 450 or 400 volta. Okay, so I'm not going to waste time testing. The important thing is to grasp the concept. Okay, right now, okay, I'm going to disconnect this resistor. That is off. Always make sure. Now, we're going to go to this instrument here. Okay, also over here, I apply the voltage through this wiring over here with the circuit protection, and the instrument is in off position. Now, I will apply the formulas and also the charts and see precisely on the smaller capacitors exactly what type of a current are we measuring. And you will see just now, okay, which is quite nice, and I'm quite chuffed with it actually. Okay, because this is the amp meter that actually is measuring the internal leakage of this resistor within the electrolytic capacitor, or even, okay, let's start with this capacitor. Okay, I'm just going to connect it up there. Okay, of course it's polarity conscious, the capacitor is not, but these two leads are, so it doesn't matter really right now on a non-polar, but on an electrolytic you must be careful, you must connect it up the right way, otherwise the capacitor will explode. Okay, so now it's connected. Now watch now the meter. Okay, let me just do this so you can actually watch it. Watch the meter. Okay, I'm going to put the highest scale, which is 100 milliampere. Okay, if it, at the initial stage, when I apply the voltage, okay, originally what I'm supposed to do is I'm supposed to vary the voltage. So I'm going to switch on. Now you can see there's no voltage, okay, and I'm going to start applying what you call it slowly voltage, but you'll see what is actually happening. Okay. Okay, let me just get, okay, let me do it this way. Let me switch off and just set this capacitor that we're measuring. Okay, I put it at the highest. Okay, I'm not going to put the 60. Okay, let's see. All right. Let's just do it. Sorry. Okay, it's too much. Okay, now it's off. Watch now. Watch now. This capacitor is connected. Watch the meter. The needle is going to jump. Okay. Come on. Let me. Okay, there is a low voltage of 25 volt. Sorry, 30 volt I got right now across it. That applies. Okay, I'm not going to adjust the unit now to wherever for because this capacitor is up to 250 volt. All right. Now watch the needle. It's gonna jump. Okay. Okay, let's do it this way. Okay, can you see? Did you see that? Because I put the scale up to 1 milliampere. So from 0 to there. So at the initial stage, when I apply the voltage, okay, let's look at it again. Look at it. Jumped up to 50%. So which means because I'm on 1 milliampere scale, full scale, it's in the middle. That means half a milliampere went shorting through the actual capacitor. Tap what in. And right now, if you look at it, there is now, I'm going to put it now the full scale according to this here, it's in microamps. Tap what in 0.28 milliampere, 280 microampere. That's a full scale on the instrument. That's a full scale, 280 from 0 to 280 microampere. It can measure. That's a minimum sort of measurement. Okay, let's disconnect and connect electrolytic one. Okay, let's take this one as beginning one. Okay, let's just get there. What value is this? Yeah, that's a. What is this here? Okay. Let's see which one we're gonna. 4,725 volt. Okay, right now I'm just setting up a power supply at 25 volt. There we go. It's on 25 volt coming over here. Right now I'm gonna apply the voltage to the capacitor. Of course, before I switch on, I always start at the highest 100 milliampere full scale. Okay, watch now. Okay, let me just shift. Watch now what will happen, okay, with this capacitor. Okay, that's a working voltage 25, and 25 volt will appear across the capacitor and be measured. Okay, so now when I switch on, look at it. Okay, just jumped a little bit. Okay, so what I can do is I can lower the scale, switch off, discharge the capacitor, try again. Can you see even more? On 10 milliampere scale. Now let's do it on 1 milliampere scale. Now look at it now. Sorry, let me switch off, discharge the capacitor. Watch now. Okay, right now it's gone. Now I'm switching it to 280 microampere. Now you can actually see on 280 microampere, the very first line that you see over there, okay, that is about 20 microamps, but yet it's on just about 0. Okay, now if I disconnect the capacitor, you can see it actually moved. Okay, it's a bit difficult. Okay, let me connect it up. Okay, let me connect it up. Can you see? When I remove it, it moves. Okay, so which means it measures about probably maybe 1 microamp, and according to the chart, a 4,7 microfarad, if you look at it very carefully, and let me just sort of zoom away. Okay, 4,7 at 25, okay. All right, and it is less than 1 micro, yeah, so it's about 12 microamps that I can actually have, up to 10 to 12 microamps that I can have the leakage through this capacitor. According to the calculations, factory given formulas, and the charts, the other charts that I have got over here, and the actual formulas. Tap what in. Okay, so right now, as I said, I take all that into consideration. I'm just showing you down the table, even over here, where I actually do the calculations and so on. And also made my own tables. And as I said, right now this capacitor is 100%. It's measuring no leakage. Okay, I start again from the highest. I switch off. You see it, it jumps. Okay, that's on 1 milliamp scale. Now it's on 200 milliamp. It's virtually zero. It's less than probably maybe half a microamp leakage going through this capacitor. So that means this capacitor is 100%. So basically, I know it's a long story and but difficult, but I hope you sort of, I hope I'm explaining it well. With these two different instruments that are made, and I trust them 100% because they are made according to do the measurements and to display the results according to manufacturers' demands and specifications, procedures and formulas, except they're homemade. And between the two, it gives me such a versatility that I can test, doesn't matter what capacitor, small, big, electrolytic, non-electrolytic, whatever capacitor I desire, I can actually measure the leakage current. And ESR estimated series resistance also gives the quality or the health state of the actual capacitor, where it's specifically more so of the electrolytic capacitors. It's more used for electrolytic capacitors where you measure ESR. So yeah, on that note, I displayed basically two instruments where I can measure and generate any capacitor up to 450 volt over here, from about 80-90 volt, and this one here from 0 to basically 70 volt. Yeah, on that note, I say thank you, and until the next video. Thanks.